everybody, and welcome to today's University of Melbourne mid-afternoon masterclass as part of Science Festival. This is the first of 5 events that are going to happen all week here at 2 p.m. Well, here being on Zoom at 2 p.m. So before I begin, I do want to acknowledge country. Today, this event is being broadcast from Wurundjeri lands, the lands of the Wurundjeri people of the Kulin Nation. Just want to pay my respects to elders past and present. The Indigenous people of this land have been looking after these lands for over 60,000 years. And this week of all weeks, it is really important to remember that the Indigenous people of this lands are our first scientists. So thank you everyone for joining us. It is very exciting. It's the start of Science Festival. It's the start of National Science Week. So what's going to happen today is that we have a couple of guests and they're going to be talking for about 25 minutes and they're going to do a presentation, and then we're going to be handing over to everyone on Zoom and you have the chance to ask some questions. We'll be going through as many questions as possible. Now, we are obviously on Zoom, so a little bit of tech housekeeping just to get us all sorted. The chat function is open, so please use that as much as possible. We really want to make this as interactive as possible, so please open that up, add some comments, and particularly ask some questions in there as well. Anything else pops up, add an emoji, whatever you feel like whatever you're feeling, just let us know. So to kick things off, just to see how we're all feeling, open up the chat and just let us know where you're Zooming in from. We'd love to know. If you open up the chat at the bottom, yes, spell right, awesome. Okay, awesome. And I was going to say, so it could be suburb, could be like state, could be country. Also, if you're from a school, let us know which school you're from as well. Riverina, New South Wales, Singapore, amazing. Parkville, Melbourne, Warrnambool, amazing. All over. This is great. A lot of staff. India, international event. This is fantastic. Welcome, everybody. Indonesia as well. Amazing. Well, welcome to everyone. So a couple more things. So the chat, that is where please place any of the questions that you have. So while you're listening to our guests, if any questions pop up, just put them in the chat. Another thing too, if you see someone else's question come and you go, that's a great question, you can actually upvote it as well. So that way it will go to the top of the list and we'll be able to prioritize that question when we get to the Q&A as well. So that chat function will be your best friend for this event. There'll also be a few polls and things like that, and that's how you can engage with it as well. Okay, so with all that done, I would now like to introduce our guests. So today we don't have one, but we have 2 wonderful scientists from the University of Melbourne, and they're both from the School of Geography, Earth and Atmospheric Sciences. First up, I'll introduce Jo. So Dr. Jo Brown, her research interests include monsoons, tropical rainfall, and the El Niño Southern Oscillation. So she uses global climate models to investigate changes in climate over a range of timescales. So she studied here at the University of Melbourne. She's worked at the University of Reading in the UK, at Monash University, at the Bureau of Meteorology, and then, of course, back here at the University of Melbourne as well. So welcome, Jo. And we've also got Ruby here as well. Ruby Lieber, a climate science researcher and PhD candidate here at the University of Melbourne. Her research focuses on understanding the impacts of El Niño and La Niña events and how they interact with extremes. Welcome to you both. Hello, how are you both?
Hi, good to be here.
Yeah, awesome.
Great to see so many people.
So many. We're up to 98 now, so quite an audience we've got. So fantastic. Well, I will sit back and pass over to both of you. Looking forward to hearing your presentation.
Okay, shall I share my screen now?
Yeah, go for it.
Okay, can you see those slides clearly, Julia?
Yeah, all good. Ready to go.
Fantastic. All right, I might get started then. So it's great to have an opportunity to speak to you all today about one of my favourite topics, El Niño. And Ruby and I couldn't resist giving this talk a subtitle, What to Expect When Climate Change Meets Our Strongest Climate Driver. And I'll explain a bit more what I mean about that in a moment. So it seems like everybody is talking about El Nino, except when they're talking about the Matildas, of course. So we've got ABC News asking how El Nino, climate change and warming oceans could combine to supercharge the world's weather. We've got The Guardian asking El Nino, what does it mean for Australia? Are more heat waves and bushfires inevitable? And we've got New Scientists talking about fears of record-breaking El Nino event this year, raising climate alarms. And some of you might have noticed our second speaker today, Ruby Lieber, was actually a guest on the Sunrise program recently, explaining all about El Nino and how climate change might be influencing El Nino and what it means for our summer ahead. So she's got a bit of a celebrity appearance there on the Sunrise program. So what is El Nino and how does it influence our weather and climate? I just wanted to give a bit of background information here because it is important to understand what El Nino really is. So firstly, I wanted to point out that it's actually a natural climate cycle. It's not caused by climate change. It's something that's been around for hundreds of years, probably thousands of years or even longer. And we know that by looking at records from corals and other kinds of natural archives, that El Nino has been around long before humans started burning coal and oil and warming up the climate. It's a natural cycle that's caused by the feedbacks between ocean temperatures, winds, and currents. And it's part of something that we call the El Nino Southern Oscillation. So you'll sometimes hear people talk about ENSO rather than El Nino. So this little cartoon down the bottom here shows us what the normal conditions look like across the Pacific Ocean. We sometimes call them neutral conditions. And we've got these very strong trade winds that blow from the east, hopefully you can see my cursor, across towards the Western Pacific there. And they blow that warm surface water across to the Western Pacific where it builds up and it forms the warmest waters on the Earth's surface in the Western Pacific warm pool. So that's to the north of Australia where it's very, very warm. But over on the other side of the Pacific near South America, as those surface waters get blown away, under the surface, cooler waters rise up to take their place. And so we end up with very cold water over on the east and warm waters over in the west. And it's this strong gradient between cold on one side and warm on the other side that drives the feedback and strengthens the winds in the Pacific Ocean. But then when we have an El Nino event, something strange happens. The trade winds weaken. And this happens on average every 3 to 7 years. And that allows the warmer waters to spread out from the west towards the central and eastern Pacific. And so now it's quite a lot warmer over here towards South America and cooler over in the east. So as I said, these events occur roughly every 3 to 7 years, and they have a kind of a seasonal cycle. So around about this time of year, from June, July, August onwards, we start to see the beginnings of an El Nino event. And meteorologists and scientists watch very carefully to see whether the Pacific Ocean is moving into an El Nino state, as they're doing right now, watching very carefully. And then by the end of the year, we have a strong El Nino event, which reaches its peak strength around December. And that's actually where the name comes from. So the fishermen along the coast of Peru noticed around every 3 to 7 years that there was unusually warm waters. And this led to a breakdown in their fishing catches. So they didn't catch as many fish in those years. And they gave it the name El Nino, which means the boy child, because they were talking about the Christmas time arrival of the Christ child. So that's where the name El Nino comes from in Spanish. Mm-hmm. So just to look at how this whole El Nino cycle can alter our climate and our weather, got a three-dimensional kind of cross-section here showing the changes in terms of the rainfall and the clouds as well. So we have firstly the normal conditions or neutral conditions with our trade winds blowing the warm surface waters across to the west and having cooler conditions over in the east. And you might know that rainfall and particularly tropical rain and tropical clouds usually form over the warmest waters. And so we have in the Western Pacific the warmest sea surface temperatures anywhere on the Earth. And this is often described as the engine of our global climate, global atmospheric circulation, because it's so warm over here in the West. So we have a lot of rainfall normally and a lot of clouds. And that's what happens in the normal state. But then in an El Nino, everything changes. Because those winds have slowed down or even reversed direction, the warmer waters move out into the central and eastern Pacific, and the rain and clouds follow. And so you can see in this little cartoon here that now it's raining over in the central Pacific and over towards South America. But over on our side of the Pacific Ocean, there's much less cloud and rain than normal. It's what we call suppressed. And so that's how El Nino can really influence our climate by moving the warm waters and the rainfall away from our coast. I should mention as well the other part of the cycle, which is called La Niña, and that comes from the opposite of the little boy is the little girl. Scientists named that one, not Peruvian fishermen. But it is basically a supercharged version of the normal state. So again, we have strong trade winds blowing across warm waters to the north of Australia and lots of rainfall and clouds over in the Western Pacific. And so that's what we've actually had for the last 3 years. Some of you have been following El Nino and La Nina might be aware that we've had a very unusual triple La Nina for the last 3 years, and that's led to lots of rain along the east coast of Australia. So El Nino and La Nina don't just have impacts on Australia, of course. They have impacts all around the world, and quite a few of you are actually joining us today from a variety of countries around the Indian Ocean and Pacific Ocean basins. And you'll see that these maps show lots and lots of different regions can experience the effect of El Nino and La Nina. So we can have drier than normal conditions, for example, during El Nino, extending from Australia up through Indonesia and also over parts of India. And during a La Nina, we have wetter conditions, again, extending from Australia up across Indonesia. And on the other side of the Pacific Basin, they'll typically have drier conditions, which is why there's been lots of droughts and wildfires in parts of America in the last few years. We can also see there are other effects like changes in frosts, changes in fires. So El Nino has lots and lots of different effects across the Earth. And we've got a question for you to pop your thoughts into the chat. So the question is, in Australia, but you can also answer for other countries if you want, what types of extreme weather or climate events are more likely during an El Nino? So have a think about either from looking back in the past or what you know about the weather and the climate, what we might expect in terms of extreme weather during an El Nino event. And we can have a look at your responses as we go along through this presentation. So how does El Nino affect Australia's climate? I'm talking here about the average conditions, not the extremes. Ruby will talk about the extremes a bit later. So one thing to point out is that every event is different. There's some typical conditions that we expect, but every event will evolve a little bit differently. So if we look at temperatures, this map shows regions that have usually warmer than average temperatures during an El Nino. And you can see most of southern Australia, and particularly the eastern parts here, usually have warm temperatures during an El Nino. In terms of rainfall, this map shows that we typically have drier conditions across most of eastern Australia and also parts of the north during El Nino events. You can see particularly for us down in Victoria, quite dry conditions expected. But as I said, every event is different. And I just wanted to give you a couple of examples to illustrate this. Firstly, back in 1997, 1998, there was a very, very strong El Nino. This was actually the strongest on record, this one, at the time. And it had very, very warm sea surface temperatures in the middle of the Pacific Ocean. but it didn't actually have such a strong effect on Australian rainfall. So this map from the Bureau shows some regions a little bit dry and others a little bit wet, but mostly not much effect. But one very important effect of this was actually on the Great Barrier Reef. So this was the warmest year on record for the reef, which lies along the northeast coast here. And it basically led to widespread coral bleaching. 74% of the inshore reef and 21% of the offshore reef was bleached in that year. And this was the first major bleaching event in the historical period. Now, unfortunately, seeing quite a number of more bleaching events in recent years. Some of them haven't occurred in El Niño years. And the other event I just wanted to mention as an example was back in 2002, 2003, a while ago now. This was a relatively weak event, but it had a really strong impact on Australia. So this is the rainfall map from the Bureau again, and now we can see the whole of Eastern Australia was really, really dry during this event. So there was droughts in a lot of regions over Victoria and New South Wales that already had a drought, and it became even worse in that year. And then we also had some severe bushfires as well that occurred following that, and in particular one that led into reached into the suburbs of Canberra that year. There was also widespread water shortages. So you can see that each event is different, and some have a stronger impact on Australia than others. So my last slide here is just to draw your attention to the Bureau of Meteorology, which is a fantastic resource if you want to know more about El Niño, not just in Australia, although it does focus on Australia. They have these nice little infographics, and they also have a regular monitoring of, it's called the El Niño Watch. And so they work out whether we're in a La Niña or a neutral, inactive, or an El Niño state, and it changes quite regularly depending on what's going on in the Pacific Ocean. So have a look at that if you want to find out what the current status is. And I think Ruby will tell you a little bit more about what's going on with the El Niño alert. So I will pop the next slide up and hand over to Ruby.
Thanks so much for that overview, Jo. So now that everyone has a bit of an understanding of what El Niño is physically and what some of those impacts are, I want you to have a bit of a think about why it might be important for us to really understand El Niño. And you can kind of think about this from different perspectives. Why might it be important for farmers, say, to understand El Niño, or policymakers, or just the general public? Yeah, have a think about that while we go on and put some thoughts in the chat. And next slide, please, Jo. So this is just to put into context where we are right now. This is a snapshot of sea surface temperature anomalies in the equatorial Pacific. So we've zoomed right up to the equator. You can see Australia poking out in the bottom left there, and Peru just on the edge. And we're really interested as scientists in that blue box that I've highlighted. So they're the sea surface temperatures that we really look for. So when we're determining if there's an El Niño or a La Niña, we analyze the temperatures in that box. And if they're above normal, that's what tells us that we're heading towards an El Niño. And as we can see, the temperatures in that box are really above normal. So we're seeing things from 1 degree, 1.5, 2, and even on the edge there, 2.5 degrees. So these temperatures that we're experiencing right now are really, really strong. Next slide, please. And so I wanted to just touch on again, why has there been so much heat in the media? And Jo mentioned before that this is one of our most dominant forms of climate variability. So globally, we're really interested in it. But I guess one unique thing about this event that has had a bit of almost controversy in the media is that the World Meteorological Organization and the kind of Weather Bureau equivalent in the US have gone ahead and declared an El Niño. They did that a few weeks ago. But our Bureau of Meteorology here in Australia is still not making that declaration. And so I just wanted to cast a bit of light on why there kind of is this disparity between the agencies. And it kind of comes down to a simple reason, is that all agencies use different definitions and different thresholds. So the Bureau here in Australia has a slightly more conservative sea surface temperature threshold that they're looking for. And we have actually reached that. But what we haven't seen so much is the atmosphere really kick into gear in the way that we'd expect. Joe talked a lot about trade winds and cloudiness and pressure patterns. And so the Bureau is really waiting for those. Next slide, please, Joe. So there's lots of things that the Bureau will look for, and they're really waiting for these 3 atmospheric thresholds to get passed before they feel confident to say that we've got an El Nino. So it's really important that we see that coupling between the ocean and the atmosphere. And so while we're getting that really, really strong signal from the ocean, we're not just yet seeing that really strong response from the atmosphere that we need. And next one, please. But we know that El Nino does have a global influence. And one thing that's being talked about a lot is global average temperature. So if we look at this graph, we've got global average temperature kind of grouped by decade. And each decade is the warmest year and the coolest year is indicated by a circle, and they've also been color coded. So if the circle's colored in red, it means it's an El Nino year, and if it's blue, it means it's a La Nina. And looking back over these decades, we can see in most decades, the warmest year does occur during an El Nino, and the coolest year occurs during a La Nina. So what happens is heat is stored in different places in the climate system, and the ocean plays a big role in that. So the ocean is capable of storing a lot of heat. And when we have a La Nina, it can store more. And when we have an El Nino, it releases some of that heat back into the atmosphere. And so the atmosphere can warm a little bit more. And so we see these peaks and troughs in the global average temperature time series. And next slide, please. And so to talk about the July that we've just had, we've just gone through the warmest July on record. And so a lot of people are pointing the finger at El Nino and asking, is El Nino the reason that we've seen these record-breaking temperatures? And I guess the answer is yes and no. So El Nino does contribute, as I just explained. It raises the global average temperature slightly, but there's lots of other factors that were contributing to this really warm weather that we've seen globally. So of course, the big bad wolf in all of this is climate change. Looking back at that last graph, we could see that those decades were just going up and up and up. And even La Nina events now are warmer than El Ninos were just a few decades ago. So we are on this long-term warming trend. So that's definitely contributing to this really warm weather that we're seeing now. And there's a few other more localized factors such as aerosols. So aerosols are little particles in the atmosphere that reflect incoming solar radiation. And a lot of dust often forms over the Atlantic Ocean. And at the moment, that dust, there's just a bit less than usual. And so we're not reflecting as much incoming solar radiation. Another big factor is local weather patterns. So a lot of the record-breaking temperatures were in the Northern Hemisphere, and a lot of individual countries saw heat waves and heat extremes that were even 1 or 2 degrees above average. And that was kind of due to local weather patterns in that area that stayed blocked for a few days and caused those really warm temperatures there. And we also have, sadly, our record low sea ice. So sea ice also has a cooling effect. It reflects incoming radiation as well. And I think I saw the amount that we're missing at the moment compared to normal is about the size of Western Australia. So it's a big chunk of sea ice is not there that we usually are. And all these are kind of contributing to why we had that really strong July last month. Next slide, please. So another question that I guess I get asked a lot as a climate scientist now that we have this El Nino developing is, what does it mean for our summer? We've seen what it did to the Northern Hemisphere summer, but what's it going to mean for us? And unfortunately, it's really hard to say. So forecasting that far in advance is extremely difficult. And as Joe mentioned before, every El Nino is different. So even if we knew exactly what the El Nino was going to look like, we can't be certain what the impacts are going to look like. But there are those general things that we can expect. And the El Nino is getting reflected in the Bureau of Meteorology seasonal outlook. So these maps don't go as far as summer, they end in October, but it's giving us an indication of what we might see for the rest of winter and then into spring. And they look quite typical of the El Nino. We're seeing that we are likely to experience drier than average conditions, particularly in Victoria and along the east coast and a bit in Northern Australia. And we basically across the continent are going to see warmer than average temperatures. The chance of exceeding our mean temperature is quite high. Next slide, please. And another kind of alarming impact of El Nino that we need to know about and be cautious about is that El Nino does also impact extremes. So we know that it raises mean temperatures, we know that it reduces mean rainfall, but it can also impact the tail ends of those distributions. It can impact the extremes. And we see cooler overnight temperatures generally during El Nino, which might be a little counterintuitive because we've talked a lot about heat and warmth and record-breaking temperatures, but for us in Australia, in the southeast, we do see cooler overnight temperatures due to a reduction in cloud cover. And this can increase the risk of frost, which can be detrimental to the agricultural sector. So it's an important one to think about. And following along with kind of the mean response we see, we would also expect hotter maximum temperatures during the day and reduced extreme rainfall, which can together lead to the increased risk of bushfire and increased risk of drought, which I saw a lot of this popping up in the chat in relation to the last poll question. So you're all spot on there. We will see an increased risk of bushfire and drought. Next one, please. So just to wrap up, what does climate change have to do with it? So El Nino events and climate change do, I guess, interact, and they occur next to each other. So when we're talking about El Ninos and La Ninas, we're talking a lot about anomalies. So deviations from the mean. We're not necessarily talking about the mean trend, which is what climate change is. So it's important to remember that all these little anomalies are happening on top of the global warming trend. So they're having an additive effect, which is concerning because we are seeing because of that the impact of El Nino on Australia is likely to intensify. That's what our climate models are telling us. And we're also likely to see an increased frequency of extreme El Nino and La Nina events. And when I talk about an extreme El Nino and La Nina event, I'm talking about the sea surface temperatures in the Pacific. So the strength of the event rather than the strength of the impacts. It's not necessarily a one-to-one link there. But as a result of this, we're more likely to see swings in our climate because following an extreme El Nino, we're more likely to see the conditions in the tropical Pacific swing to an extreme La Nina. And as a result of that, our climate is likely to swing from heat waves and drought to flooding rains. And unfortunately, it is more likely that we will see more and more record-breaking temperatures as we are on this global warming trend and we see El Nino events on top of that. So I'm sorry to end on kind of a dire note, but that's the end of our presentation. On the next slide, we've got a few links. So if anyone's interested in reading more, keeping an eye on the Bureau, the updates on whether an El Nino will be called or how the seasonal outlooks are going to play out, have a look at some of these links, and yeah, ready for questions.
Thank you so much, Ruby and Joe. That was fascinating. And yes, I guess we did end on a slightly worrying note, I guess, but that is where we're up to. But generally speaking, it's just such a interesting, relatable, like we're all in it, you know, and I think it's so fantastic to hear more about it. And I knew it was called The Little Boy, but I didn't know why. So it was the Christmas element. I get it. I get it now. Makes sense.
Learn some Spanish.
Sorry?
You can learn some Spanish.
Yeah, exactly. I know, learning a different language. This is great. So thank you to both of you. So we've got 10 minutes or so of questions. That's great. We've already got one in, so I'll throw it to you already. So it's from Catherine. Thank you so much for your question. So do you know the reasons why we just had 3 La Nina in a row? So I'm not sure who wants to take that one.
I could have a go, and then Ruby can have a go. That's a really great question. And as it turns out, no, we don't know. So there's a lot of active research at the moment. A lot of climate scientists are studying that very unusual triple La Nina and trying to work out if it was perhaps in some way related to climate change or if it was just a kind of a natural coincidence. But Ruby might have more to say on that.
Yeah, I'd agree with Jo on that. So it was a very rare occurrence. There has been a couple. I think this was the 3rd one since 1950. But I'm actually just going to post a link in the chat to a briefing note that a colleague wrote that talks all about the triple dip La Nina and has a lot of really nice facts in there. So I'll just quickly pop that in the chat for everyone as well.
It's amazing. Thank you so much. And I guess, Jo, that really extends to just the fact that there's so many factors in all of this. And it's just so hard to have to point to one specific reason or cause or anything.
It is, yeah.
Why this is a whole field for you both to be studying. There's so much work to be done, I guess.
Exactly.
Okay, all right, next question. So Mahir Joshi, to what extent does El Nino influence marine ecosystems? And is there any solution for it?
So, I mean, I talked a little bit about the Great Barrier Reef, and obviously coral reef ecosystems are very sensitive to high sea surface temperatures, which we have seen in naturally in El Nino events. We'll have those warm temperatures, but then, as Ruby said, we're adding an extra amount of warming on top of that with climate change, and that seems to be what's causing these bleaching events where we have an El Nino that would have been a certain temperature is now a lot warmer again, and the marine heat waves are lasting longer. So I think, coral is one very sensitive ecosystem, but there are a lot of others. We've seen the kelp forests, the seagrass, a lot of the marine animals, and fisheries are actually sort of moving. So we're finding them, turning up in places that they've never been before. So there are natural cycles, but we're kind of in a way changing those natural cycles by adding in that extra warming from human activities.
Yeah, right. So in a sense, I guess there's a lot of marine ecosystems that would have adapted to the El Nino moves or changes and variability, but not to the extremes, I guess, that we're moving to.
And I guess that's where the names come from, because it was the fishermen who really noticed, because it was their fishing catchments that were getting impacted, because the kind of upwelling and downwelling impacts how nutrient rich the water is in those areas.
Of course. Yeah. Awesome. Okay. Great. Thank you for all the questions, everyone. Keep them coming. So Nicole, what impacts do El Nino and La Nina have on global ocean currents?
So I guess it's all connected in a way that the currents impact on the sea surface temperatures, which impact on the winds, which feed back on the currents. So that's why I talked about this positive feedback cycle. So we do see, when there's an El Nino, we see less of that upwelling of the cold waters along the South American coast. And we see a weakening because the trade winds, which push the surface currents across from east to west, are weakened or slowed down. Those currents are also weakened. So in the equatorial region, it's those surface wind-driven currents that change, but then obviously that's connected to the whole global ocean circulation as well. So it's a very complex and interconnected system. All
interconnected. I love it. Amazing. We've got a few more questions coming through. I'll just wait for them to come through. But I actually do have one, because I looked at the what was it, the threshold that the Bureau of Meteorology haven't reached, but no, I have. What does that change while it might label it as a El Nino event or not? What flow on effects, I guess, does that have in terms of how we deal with it, or is it just simply we've labeled it as a El Nino event or not?
Yeah, I mean, I don't really know what like the Bureau's processes are in terms of how they interact with other, I guess, government agencies in terms of if any kind of risk preparedness things happen. But I guess the impacts that we see, regardless of whether or not it's named an El Nino, won't change. Like if the sea surface temperatures are warm, but not quite warm enough, but we still get reduced rainfall, we're still going to get it. But yeah, so I guess, and either way, we know that we might see changes based on the conditions. So I guess what's in the name? But I'm not.
Yeah, I guess so. All right, so Jonathan's sent one in. So are the incidents of El Nino and La Nina changing, or is the cycle remaining consistent, like over, say, hundreds of years?
Over hundreds of years, it seems that there are actually natural fluctuations in the system. I mean, we don't have direct measurements going back beyond about 50 or 100 years from like, thermometers and so on, but we can work it out from looking at things like corals and other like tree rings that are sensitive to El Nino. So we can find natural cycles that do, in terms of the strength of El Nino events and so on. But it seems like in the last few decades that there have been sort of noticeable changes relating to the warming climate. So this sort of strengthening of there's more extreme El Ninos, more extreme La Ninas, as well as larger impacts, as Ruby was saying. So we're possibly taking the natural variability and amplifying that, if you like, making it even stronger.
Yeah, moving to those extremes. Great. Okay, so Gayatri, how does the El Nino impact human health? Okay, so going into more of the human effects, this is great. So maybe any like diverse impacts regarding sort of heat stress, malnutrition, any flow-on effects there?
Totally. There's been quite a bit of research from some people in our school actually about this. And so we know, for example, heat stress is a big one. There's also been linked to changes in vector-borne diseases, I think. So there's, and also migration. So there's quite a few links to El Nino and human health for sure. I wouldn't say I'm an expert in that, but there are a few reachers in the School of Geography that do look at that.
Yeah, I mean, as Ruby was saying, some of the natural sort of vector-borne diseases like malaria and so on and dengue will move around depending on raininess and warmth, and so they will be impacted from year to year, whether it's an El Nino or a La Nina year. And then when you add climate change into the mix as well, I guess you've got to consider they're expanding the regions that those diseases often can occur in.
Yeah, I guess that's where the collaborations come in, where you can do your work and pass on the the details of El Nino and La Nina onto other scientists that can be working a little bit more of the human focused geography work.
Yeah.
Great, thank you. Okay, so all right, so now one from Cassandra. Thank you, Cassandra. So how does the Indian Ocean dipole impact El Nino Southern Oscillation, if at all?
Yeah, so the Indian Ocean dipole and El Nino can co-occur, and they can act to amplify or dampen each other. So more so on like an impacts take, if we have an El Nino and is it a positive IOD, then we get an enhancement. So the drying will be more and the warmth will be more, if that makes sense. They amplify each other.
So the Indian Ocean dipole, for those that don't know, is kind of similar. We have kind of an oscillation between warmer and cooler on the two different sides of the Indian Ocean, and that can lead to changes in the weather and climate similar to ENSO, and it also has quite a big impact on Australia's rainfall because a lot of our moisture comes across from the Indian Ocean down across, particularly for southern Australia. So yeah, when we've had a few long periods of drought, for example, it seems that was linked to a lack of La Ninas and also negative Indian Ocean dipoles, which are what brings us heavy rains. So they sort of act together in that way, as Ruby was saying.
It's amazing the things that influence the weather just keep adding up. It's such a complex thing. Amazing. Okay, so I guess this is a bit more of the implications again. So Nadia, so are there challenges for scientists in convincing developed countries to implement specific policies for climate change? Not sure whether you can speak to either of that.
Developed countries.
Yeah.
Yeah, I mean, obviously, as climate scientists, we've been talking about this for a long time now, and we've been talking about the urgency of it for a long time now as well. But we definitely haven't seen a response that is, the right sort of level of seriousness to really turn things around. And so that's why, even though we've known what we needed to do for a long time, we still have a rising, greenhouse gas emissions year on year. We still have temperatures getting warmer and warmer every year. So yes, it's a very urgent problem, and something that we can provide the science, we can provide the information, but at the end of the day, we're not the ones that really have, decision-making power. So we have to rely on governments and policymakers and everyone else to actually make the decisions and implement the solutions.
Yeah, absolutely. Well said. Okay, so we've got not long to go. I've got another one here from Marsa. It's a bit of a long one. So she starts off with by saying, thank you so much for your fantastic talk. So thank you from Marsa. So I have a question about the two El Nino events that you mentioned in your talk, 97 and 2002. As you mentioned, El Nino 97 had a remarkable impact on marine ecosystem rather than the land. Do you think this could be attributed to the interactions with other climate modes, like monsoons, Joe, your fave, that may have influenced the impacts of El Nino on the land?
Yeah, one of the things I didn't really talk about with those two events were that the location of the warm temperatures was a bit different. And so the 2002, 2003, the warmer temperatures were actually more in the central Pacific. Scientists have recently discovered that there are two different types of El Niños. They call them flavors, which is a bit funny, but basically some that are in the central Pacific and some that are further over in the east. And so the 2002, 2003 was in the center, which meant that it was closer to us. And I think that's why it had more of an effect, whereas that other one was further over, away towards the South American coast. As to why that one had a stronger impact on the Great Barrier Reef, I don't actually know the details. I guess it could have been interacting with some local currents, and maybe even the monsoon might have been, particularly weak that year as well. So there could have been some local factors in contributing to that marine heat wave.
Yeah, right. All right, so we've got maybe 2 minutes left, so I might just take this time to ask you one final question. So, I mean, Ruby, you're finishing off your PhD. How far? I guess my question is, what's next for both of you? So, Ruby, how far to go with your PhD, and then I'll pass on to the what's next question to you, Joe, as well.
Yeah, sure. So I'm in that stage where it's hard to say, 6 months to a year. I'm approaching my three-year mark next March. But we'll see if I've managed to get it all finished by then. And as for what's next, I get asked that question a lot and I don't have a good answer for you. I'm sorry.
What are you going to be when you grow up? We all love that question. And Joe, what's your focus at the moment?
I'm actually really interested in looking at how we can learn from the past. So I look at what we call paleoclimate back to thousands of years in the past, and try and understand how things like El Nino or the monsoon changed in past climates that are really different from today, and use that kind of information to understand better how those systems respond to big changes.
Amazing. Well, as we've heard today, there is so much work that could be done in this field, and it's the complexity is just continues to amaze me. So thank you so much for your presentation and for shedding some light on some of this for the audience. So thank you, Ruby. Thank you, Joe. And thank you to our audience as well. That was amazing. It was sort of over 100 participants at one point. So amazing to see you all. Thank you so much for coming, and thank you for all your questions. Final final word to everyone as well, obviously, not obviously, but to let everyone know, if you don't know, we're going to be presenting a mid-afternoon masterclass at 2 o'clock Melbourne time, should I say. I know we've got some Indian and Indonesian guests as well. So yeah, we're back here tomorrow, 2 o'clock Melbourne time. We're going to be talking to Dr. Hayden Dalton on with volcanoes that carry diamonds. I mean, it's going to be continuation of some really interesting science. So I hope to see you all there. Thank you, Joe. Thank you, Ruby, again. Thank you, audience, for coming. And hopefully see you tomorrow at 2 o'clock.